is to optimize the biomass utilization by encouraging the development of biomass or RDF for co-firing. And for the co-firing, currently around 115 unit current coal-fired power plant owned by PLN will implement the co-firing in 42 locations with a total capacity around 18 gigawatt. And the implementation, it will be starting this year. Around 4 CFPP or coal-fired power plant already in commercial phase to implement the co-firing. And for the biofuel implementation, as you know that Indonesia is now already implemented a B30 program. It started in this year. And for the future, we will develop the green refinery to produce green diesel, green gasoline, as well as green after. And then also we conduct the supporting technical and economical study for green fuel development and develop the supporting industry such as industry for the methanol and also for the catalyst. The other strategy is implementation of sustainable biogas program. We develop a sustainable biogas program now on the progress and encourage the biogas development for domestic purpose and small micro medium enterprise. And also promote the development of commercial scale of bio-CNG for transportation, for LPG substitution, for industry and power generation. This is for policy and strategy for bioenergy development in Indonesia. And then now we move to bioenergy program and implementation. For the bioenergy power plant, we already installed with the capacity around 1.9 megawatt, which is around 1.6 gigawatt is on off-grid, and around 210 in on-grid. And this is some example of our bioenergy power plant. It can come from the biomass, the feedstock come from the biomass, biogas, municipal waste, and as well as from a CPU. For the municipal waste, as I mentioned before, that we have the regulation, presidential regulation to accelerate the implementation of municipal waste to energy in the 12 cities. And around 3 of these cities already signed the PPA, and 2 already have the developer, and the other is still on the process of tender. This is the figure of distribution of domestic biogas. Currently, we already built around 47,000 units of domestic biogas. It's spread in 31 provinces in Indonesia, and it's built by the Ministry of Energy and other ministry, and also support by the donors such as HIFOS and also the private sector. And this is for the co-firing biomass, the implementation of biomass co-firing. As I mentioned before, that we hope by substitution of the energy, we hope that we can catch the target that already set in 2025. And we see we already do some activity to encourage the implementation of the co-firing biomass. And if we see regarding the off-taker, we already have the PLN as off-taker. It's around 114 coal-fired power plant in 52 locations. And also the other industries such as cement, it's around 34. Cement industry already can be as off-taker. And if we see the feedstock, actually, we also have a lot of feedstock, but currently the main problem is regarding the price. So now for the short term, we encourage the implementation of co-firing based on the municipal waste or the agriculture and forest residue. But we hope for the future, we can also move to the energy crops. This is the location of co-firing in Sumatra, Kalimantan, Java, Sulawesi, Bali, and Nusa Tenggara, as well as in Maluku. And the PLN already conducted some trial on the co-firing, and 4 of coal-fired power plant already commercial phase, and we hope the other coal-fired power plant will follow to be go into the commercial phase. This is the roadmap of biomass co-firing, but it's still in discussion actually, because we need to discuss with the other stakeholders, particularly in feedstock sustainability. In this roadmap, we divide 3 phases, the first phase, second, and the third phase. So in the short phase, we more concerned on using the waste for the feedstock. And in the future, we hope we can encourage the energy crops to support the co-firing program. For the biofuel development, as I mentioned before, that in 2020, we already start with B30. And this is one of the renewable energy program we can say that quite success in Indonesia. From this figure, we can see in 2020, the target based on the energy plan, national energy plan, is around 8 million kiloliters, and we hope we can achieve around 8.5 million kiloliters in 2020. Even in the first allocation, we already set in 9.6, but due to the pandemic COVID, the achievement is reduced because of some activity has been stopped, particularly in transportation. It's very get the impact on the COVID pandemic. But based on the target set in the National Energy Plan, around 8, it can be achieved in 2020, and we hope in 2025, we also can increase the implementation of biofuel. For the biorefinery development, Pertamina is very eager to develop the biorefinery, biohydrocarbon. The trial and research already started since 2014, and Pertamina also will build the standalone biorefinery, the new one in Cilacap, and for the revamping, the new one in Pelaju, and for the revamping in Cilacap. So we hope in the future we also can increase the renewable energy in transportation sector. Besides the green diesel, we also encourage to produce the green gasoline. It can come from the co-processing process in the current biorefinery. For the closing, I think this is some challenge and opportunity for bioenergy development program. We realize that we have a lot of potential, but unfortunately, until now, the implementation is still far from the target. For the challenge and opportunity for the feedstock, we have a lot of feedstock, but we need to make sure that the potential conflict between the use of raw material can be minimized, and also the guarantee of feedstock sustainability and biomass price stability is also one of the challenges in bioenergy development. The other things is readiness of supporting industry, such as hydrogen industry to support the green fuel project, and then methanol industry, catalyst industry, and also industrial vegetable oil industry. And the other challenge is funding and incentive, because we know that for the renewable energy as well as for the bioenergy, there is the lack of funding for this project. We hope that in the future we can increase the support for the renewable energy, particularly for the bioenergy. And for the infrastructure, because Indonesia is the archipelago with a lot of islands, so we also have another challenge regarding the infrastructure. So we hope in the future we also can build the good infrastructure to support the distribution of biofuel and the other project on renewable energy. And also the quality of assurance and product quality, it's also the challenge for us, and the technology availability and innovation. And from this seminar, we hope BPPT and NEDO can support the bioenergy development. There is some idea how the BPPT and NEDO can support. The first one is we encourage the Japanese private sector to invest in bioenergy projects in Indonesia, and also develop bioenzyme, catalyst, and additive to modify industrial process to produce reliable and affordable bioenergy product, and also to develop research and development to improve biomass productivity, and also develop study on micro or small scale power plant, and also conduct studies on development of X1 generation biomass, which is environmentally friendly, efficient, and economically feasible. I hope from this seminar we can share knowledge about the technology and also innovation on bioenergy development. Thank you very much.
Thank you very much, Ms. Andrea, for your sharing today. I believe it's very informative for all the audience today. We are now updated on the latest policies, not just related to biomass or biorefinery, but also renewable energy in general in Indonesia. As for the Q&A, please to the audience, you can give question or comments on the Q&A chat, and please mention to whom the question is addressed to, and also please mention your name and affiliation. The questions can be written in English, Indonesian, or Japanese, and later we will interpret it. So let's move to the next presentation. Today, our second presenter is Mr. Joko Winarno from the Indonesian Biomass Energy Society, or Masyarakat Energi Indonesia. He will present today's topic on biomass potential in Indonesia. And Mr. Joko Winarno is also a commissary of PT Elektro Indonesia Mandiri, and he is also a project consultant of PT Indo Power International from 2015 until now. And for the organization, the Indonesian Biomass Energy Society he is today is representing, it is an open professional organization representing stakeholders in the development and utilization of biomass for energy. The Indonesian Biomass Energy Society, or MABI, intends to gather the potential of various parties related to and with an interest in renewable energy to create a condition that is complementary and synergized in the efforts of Indonesian people to build a quality, reliable, and efficient biomass energy system with competitive prices affordable to the wider community. Okay, so for today's second presentation, please, Mr. Joko Winarno, the screen and time is yours. Silakan Pak Joko.
Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Distinguished guest, Mr. Hamam Risa from BPPT, Mr. Yuruki from NEDO, and Ibu Andrea VP Misna from Bioenergy. Maybe you can share the presentation.
Oh yeah, from the organizer,
Yes.
could you please help us to share the presentation of Mr. Joko Winarno? Okay, we can wait a little bit. Maybe while waiting, Mr. Joko, you can share with us a little more about your organization.
Yes, I will present this by the biomass potential in Indonesia. But I think all the potential already mentioned by Ibu Andrea, and then I make this our overview of our next. Yeah, overview is our Indonesian Biomass Energy Society. IBES was declared on September 15, 2020. IBES vision to become a leading professional organization in the development of biomass energy to support the national energy security and economic in sustainable manner. Purpose and objective: increasing public energy access through the use of renewable energy can encourage economic growth and care of the environment, which is the line with the philosophy of pro-growth, pro-job, pro-poor, and pro-environment. Number two, breakout efforts are needed in accelerating, expanding, and development the use of biofuel and the use of biomass as a source of electricity. Three, a breakthrough effort that can be made by the government is the Energy Forest Development Program. This program is an effort to develop biomass raw material, which is very strategic in the nature by involving the community in ensuring the availability of the raw material and biomass production. Next. Role and contribution of forest plan. There is a local need for diesel power plant and coal-fired power plant, which its fuel will be covered into biomass. Local industry of factories that use boilers in Java initially use coal and palm kernel shell, but the availability of the palm kernel shell in Java was decreasing because they were mostly exported. Dependence of more than 2 million people on biomass for cooking and heating. It takes 10% of the land to obtain certain amount of firewood. Indonesia energy supply is 85% of fossil energy. While alternative energy has not been full development, bioenergy contribution was 8.2% in 2015. The availability of fossil energy, while forest land is still quite extensive. The reserve HTE area is 2,245,364 hectares. The reserve R of the HTR is 702,519 hectares. Next. Potential for crop forest development. Forests are 70% of land area. Production forest 74.44 million hectare, 62.57%. An area of 36.99 million hectare has not been burned with permits, of which 10,000.06 million is reserved for forest permit. The area of forest permit is 28.99 million hectare. HPT is 28.41 million hectare. HPK is 18.4 million hectare. Plantation forest is 5 million hectare. Wood production is 21 million cubic meter per year. Next. I think this potensi biomasa in Indonesia. You can see that. Next. The role of IBES in creating biomass-based energy, increasing professionalism of human resource through education and training, workshop, symposium, seminar, lunch and talk, and other, either independently or in collaboration with other agencies. 2. Developing network and cooperation between stakeholders in Indonesia and around the world through the connectivity of biomass energy organization and digital data collection system from the upstream, downstream sector. 3. Optimizing the use of communication media, mass media, and other media for the dissemination of the IBES activity and research result to stakeholders. Providing input to government in public policy and handling strategic issues related to the development and utilization of biomass and biomass energy, as well as national energy conservation. Number 4, encouraging increased added value in competitiveness through increases productivity and cost efficiency production in the upstream, downstream sector, as well as acceptance of incentive as environmental friendly green product. 6. Encouraging the development of biomass energy as a business unit that has good prospect for supporting increased employment opportunity and employment. 7. Building coordination, cooperation, and consultant roles in the effort to create cohesiveness and synergy between stakeholders through the MEBI forum, as well as assessing biomass expert to be certified accredited. IBES can make this happen together with other stakeholders. Next. Figure of the potential of biomass power plant and waste in Indonesia, 32,856 megawatt, as well as HTI and area. This is the total in Aceh, 11,000 hectare, Jambi, 22,000 hectare, Bangka Belitung, Sumsel, and all the Sumatra, we have potential for 15,588 megawatt. Java Bali, total Java, we have 13,860 hectare. Jawa Bali Madura have the 9,215 megawatt. Kalimantan, we have 100 on the Kalimantan Barat, 429,000 hectare. Kalimantan Tengah, 108 hectare. Kalimantan Timur 100,000 hectare. Kalimantan Selatan 97. The total Kalimantan we have potential 5,062 megawatt. Sulawesi, Gorontalo, Sulbar, and Nusa Tenggara total is 1,937 megawatt. Maluku, we have the 96 megawatt. Papua 151 megawatt. Also Nusa Tenggara, we have potential 636 megawatt. Next. The potential of energy plant, PLN, is already presented by the Ibu Fabria. Next. This is also the PLN already presented by Ibu Febi. Next. Also, this is the biomass pallet waste for the waste to waste. We have the total is 20,025 ton per hour. And then there's the forest product, many, the pellet. Now, this is all the potential of the waste. Next. Okay. And then we have the presentation, but maybe it's only for your itu. So many. I put the location of the total of the in the Aceh, the mile of the palm oil. This is already mentioned that. Also, we put all the location of the diesel or power plant there to make synchronize the potential in every location. I think this is my presentation. You just you can take all the data. This is we have the because Indonesia have the more than 1,000 palm oil mill. This is also we have the diesel power plant will be replacing by the biomass power plant. Thank you.
Thank you very much, Mr. Joko Arno. Well, actually, we can call you also Pak Jokowi ya, Pak ya. Pak Jokowi boleh ya, Pak?
Jokowin.
Another Jokowi. Okay, thank you very much for your presentation. And I think it's very interesting because the association is a very important stakeholders to give a suggestion as well as a place to discuss between different various various parties who are interested in biomass, and then you can give a suggestion to the policymakers as well as the technology developer. So thank you very much for sharing with us about your organization as well as some data. Thank you very much. All right, so we will move to the next presentation. So today we regretfully cannot have Miss Enia Listiani Dewi to present her presentation today. But don't worry, because we already have a representative here with us, Mr. Sri Jangkung Sumbogo Murti. Today, he, as the Program Director of Technology, Innovation and Services for Chemical Industry Agency for the Assessment and Application of Technology, PPPT, will present Ms. Enia's presentation on behalf of her. So here, he is my colleague here in PPPT, and his experience and organization is he also ever lead the BPPT Bioenergy Program, Chief Engineer of Biofuel, and also Associate Engineer here in the Center of Energy Resource Technology and Chemical Industry. Okay, so as a reminder, again, for each presentation, we have around 15 minutes. Please use the time wisely. So to Mr. Sumbogomurti, the time and screen is yours.
Okay, thank you very much. Can you hear my voice?
Yeah, from my side, it's very clear.
Okay, can I share the screen, please?
Okay, yes, we can see your slides, Pak Sumbogo. Thank you.
Ini bukan us. Okay, thank you very much. Okay, thank you very much. First of all, I would like to convey an apology from Professor Enya. Hmm? Ini. Okay, share screen. Yeah. Okay, first of all, I would like to convey the apologies from Professor Enya because there is a DPR in our office. Ladies and gentlemen, the Honorable Chief Representative of NATO Asia Representative Office, Ms. Yurugi Yoshiko, the Director of Bioenergy, Ibu Febi Misna, the Chairman of the Indonesian Biomass Energy Society, Bapak Joko Winarno, and also CEO Clean Power Indonesia, Bapak Jaya Wahono. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera, Om Swastiastu, Namo Buddhaya, salam kebajikan, konnichiwa. On these occasions, I will, on behalf of Professor Enya, will talk about the biomass utilization technology in Indonesia. As we know, the COVID-19 pandemic has hit Indonesia since the first case was detected and officially announced by the government in early March 2020, affecting almost all sectors of socio-economic life. The energy sector is one that has been significantly affected by the COVID-19 pandemic. The large-scale social restriction policies pose a challenge in implementing the national energy management plans that have been made by the governments, such as the National Energy Policy, the National Energy General Plan, the Electricity Supply Business Plan, and limiting community activities will directly reduce demand, including energy demand. Electricity consumptions will decline due to the restriction novice business and manufacturing industry activities. Decreasing energy demand will also reduce energy supply. At the present, the energy mix condition in Indonesia still needs acceleration to reach 23% by 2025, or the required equivalent of 94 MTOE. Indonesia energy consumption needs are still very dependent on fossil energy. More than 90% of national energy consumption come from the fossil energy. As national energy company, Pertamina is facing a huge challenge to ensure that Indonesia energy sustainability. Production reduced significantly while product demand increased at around 4 to 5% per year. Indonesia's fuel import requirement could reach 1 million barrels per day in 2020, and energy diversification is a must for Indonesia to fuel its economic growth. Indonesia is rich in oil palm plantation. In 2018, Indonesia's CPO's production reached 41.6 million tons. And in 2025, if all Indonesian oil palm plantations bear fruits, it is estimated that they will produce around 51.7 million tons of CPO. This CPO has the potential to accelerate the fulfillment of 23 new renewable targets by 2025. Indonesia can also use its biomass to accelerate the achievement of 23%, such as to substitute fuel import 20% or 80,000 barrels per day and reducing current account deficit. A solution for oversupply CPO and thus utilizing biomass to provide farmers added value. Relevant to support renewable energy target of 20% of national energy mix in 2025, and thus provided a better energy security. Biomass is the only renewable energy resources that can replace oil from fossil energy, which is very limited. Only biomass that can be used both as a source of fuel energy and for electricity. This is a chart of Bioenergy Development Program Indonesia, where this was explained detailed by Ibu Andrea Misna. And then Indonesia is the largest CPO producer in the world. BPPT supports the government program, namely the application of B30, mixing diesel, biodiesel as much as 30% of biodiesel in diesel fuel. Biodiesel can reduce diesel import, but also create jobs. The following is oil palm, which is an energy industry crop that contributes a lot to the country's foreign exchange. All components can be used as an energy source, starting from the fruits for CPO production, oil palm, empty bunch, and shell can be used as a fuel for power plants. In the front, can be converted also into bio-oil, even liquid waste in the form of pome, palm oil meal effluents, can be used for electricity generation. The following is the potential for biomass in Indonesia, whereas palm biomass is one of the biggest potential because palm oil is cultivated to produce CPO for export and for domestic purposes. From this oil palm cultivation, several benefits will be taken, such as palm oil mist, 30 ton per hour FAB, can generate electricity around 3 to 4 megawatt from biomass power plants, and also 1 megawatt from biogas power plant comes from pome. And in Indonesia, there are about 700 units of palm oil mills nationwide, with an average production capacity around 30 to 45 tons per hour of fresh fruits bunch in general, that can generate electricity for 3,000 megawatt from biomass power plant and 1,000 megawatt from biogas power plant from pome. Apart from biomass from oil palm, we also still have many potential sources of biomass, including Kaliandra, Turi Lamtoro, etc., that must can be found around Indonesian. We at BPPT are in accordance with the direction of the President of the Republic of Indonesia to develop fuel by making energy plantation when the produce from this plantation is dedicated to fuel. Utilization of this kind of biomass is one of the breakthrough in fulfilling the target of 23 EBT in the energy mix 2025, and in addition to creating national energy security. In relation to this activity, biodiesel, the second generation fuel, will be made, and the second generation biofuel will use oil palm biomass as a raw material to process into bio-oil, and then the bio-oil is upgraded to meet the specification for the motor and vehicles. From this activity, it has been proposed to the Minister of Energy and Mineral Resources regarding energy plantation and has received a positive response from the Minister. And hopefully, this can also accelerate the achievement of the 23% target. And in addition, PPD is also developing necessary technology to obtain the new seeds which quality the best. This is the biogas gasification scheme, which is a collaboration between BPT and Gunma University through the SATRAP program, JICA. In these collaborations, a biomass gasification technology has been designed with dual fluidized bed gasification technology using biomass as a raw material from palm oil. Biomass gasification can convert the biomass into flammable gas, which can be used for electricity generations and heat productions. The gaseous product can also be upgraded to other valuable products such as FD fluids, hydrogen, or even as chemicals. The output capacity of this biogas gasification design is 50 kilowatt electric with oil palm biomass feed as much as 200 kilogram per day. The byproduct of biomass gasification here is used as a matrix for NPK fertilizer, which is using to provide nutrition for onion plants, and the results are very encouraging. This is about the biogas from the pomace. The amount of pomace from palm oil mills is very large, and if it is not processed or utilized, it will have a negative impact, especially the achievement of zero waste, added value for waste, and eco-friendly. So the utilization of palm oil mill effluent into energy is the best solution to overcome the negative impact caused by pomace. The processing of pomace into products will increase the profitability of the palm oil mills, namely biogas. Biogas can be used as a source of fuel for boilers or to generate electricity itself. The electrical energy generated is often used for internal factories in the form of power source from the kernel crushing plant, offices or housing for factory employees. And in addition, a scheme for selling electricity to PLN can be carried out. And BPT has succeeded in making a power plant from pomace using a copper lagoon technology with a capacity of 700 kilowatt electric to 1 megawatt electric at Trantam Palm Oil Mills, Riau. This is collaboration with PTPN 5, and the electricity generated is used for oil canal factory. This is the proposed for use of energy from biomass in the context of Indonesian energy mix. The first can reducing fuel imports and also potential to create new business for the people, agriculture sector and mechanical industry, also job creations and the effort to achieve the farthest EBT target compared to other EBT alternatives. And the last one is reducing greenhouse gas emission meets sustainable development goals. And the last one, BPT supports biorefinery research and innovations through national and international collaborations. And let us use science and technology resources in the field of energy for national development. Thank you very much.
Thank you very much, Mr. Sumbago, for sharing with us. I think your sharing is more about technology aspect. So today, I think we have quite, various perspectives regarding biorefinery or biomass here. So, I need to remind the audience for the Q&A session. You can ask questions and comments on the Q&A chat. You can use Indonesian, English, or Japanese, and later we will have a special session for Q&A at the end of all the presentations. Okay. Oh, I'm sorry. I just have trouble with internet connection here, so I just come back. Okay, shall I continue? Maybe I repeat a little bit. So for the fourth one here, we have from private company. Can you all hear my voice clearly?
Yes.
Okay, thank you. So we have Mr. Jaya Wahono. He is the CEO of Clean Power Indonesia. He is also the member of Indonesian Chamber for Renewable Energy and has been promoting 100% renewable energy target by 2030 in small islands all over Indonesia in order to bring affordable, sustainable, reliable, and equitable electricity to its population. And his company overview is the Clean Power Indonesia is the first company that implement the concept of community-based biomass distributed power for rural or island communities. They use bamboo and other forest-based biomass for feedstock supply and focusing on biomass gasification technology. So today's presentation, he will talk about biomass gasification specifically, but also I think he can also share about other projects from Clean Power Indonesia. So please, Mr. Jaya Wahono, the time and screen is yours.
Okay. Thank you, Mbak Novi, for the time that you've given me. Thank you also, Pak Hamam Riza and Yugeso Son, the Chief Representative of NEDO in Bangkok, Ibu Feby, representing Bapak Bondan Gustiana, and Bapak Sumbogo, representing Ibu Enia. Please, the organizer, can you play the video that we have submitted? And I will not play my video or my camera because I want to save some bandwidth. Go ahead. There is no sound. Can you make sure about the sound? Thank you.
Sumatera Barat kini bisa menikmati listrik untuk pertama kalinya sejak Indonesia merdeka. Aliran listrik yang menerangi hidup mereka dihasilkan pembangkit listrik tenaga biomasa atau PLTBM berbahan bakar bambu. PLTBM berkapasitas kapasitas total 700 kW tersebut menghasilkan listrik untuk 1.233 kepala keluarga.
Setelah adanya listrik masuk di desa kami ini, kami boleh nonton TV dan juga kami bisa bekerja baik malam dengan kegiatan-kegiatan baik di pemerintah maupun di masyarakat setempat. Dan kami bersyukur dengan adanya penerangan di tempat ini, kami boleh meningkatkan segi perekonomian kami baik untuk hari ini maupun untuk hari-hari yang akan datang.
Dengan adanya listrik ini juga akan memotivasi masyarakat untuk meningkatkan taraf hidupnya untuk cara yang lebih baik.
Potensi penghematan yang akan diperoleh dari PLTBM dibandingkan PLTD adalah 14 miliar rupiah per tahun.
Dengan menggunakan bahan bakar bambu ini jauh lebih rendah, dan kita alhamdulillah di PL ini kita bisa menekan efisiensi 70% untuk biayanya dengan menggunakan bahan bakar EBT bambu.
Selain penghematan, pendapatan masyarakat juga meningkat dengan adanya pembelian bambu dari kebun masyarakat setempat dan penyerapan tenaga kerja sebesar 2 miliar rupiah per tahun.
Bambu mereka tanam atau yang mereka punya, mereka jual ke PLN menghasilkan duit. PLN atau biomasa ini memproses menjadi lampu, menjadi listrik, dikembalikan lagi kepada masyarakat. Minimal itu menjadi suatu manfaat yang sangat berguna sekali. Selain tadi ada penghematan BBM fosil.
Pembangunan 3 PLTBM ini mengusung konsep 3-in-1 development. Pertama, PLTBM menyediakan energi listrik untuk daerah yang sama sekali belum teraliri listrik. Dengan pembangunan pembangkit ini, Indonesia dapat menambah rasio elektrik nasional. Kedua, PLTBM menjadi salah satu upaya pengembangan energi baru terbarukan atau EBP, khususnya tenaga biomasa yang masih belum banyak dikembangkan. Ketiga, pembangunan PLTBM ini juga bagian pembangunan daerah 3T, akan tertinggal, terdepan, dan terluar.
Ini adalah inovasi yang luar biasa karena akan mempercepat proporsi energi terbarukan dalam komposisi bauran energi nasional. Yang tentunya kita harapkan tahun 2025 kita sudah mencapai 23% energi mix berasal dari energi terbarukan.
PLTBM menjadi jawaban untuk memberikan akses listrik merata bagi masyarakat di salah satu gugus pulau terluar paling barat Indonesia yang sudah lama tidak menikmati listrik sejak Indonesia merdeka, seperti di Pulau Siberut.
Thank you, organizer. So I will put up my presentation first. Can you all see it? Moderator, can you see?
It's still just black. So maybe we have to wait a little bit, or maybe you can repeat the share screen again, because we can only just see the black box right now.
How about now? Can you see? It show up in my screen right now.
Is there something written on it? Because this is only black, like blank black box for now. Can you try to click next?
Yes, I did.
No, it seems we cannot see the content of the presentation.
Okay, hold on. How about now? Can you see?
It's still the black blank box.
Okay. Can the organizer share the presentation from their side?
Yes.
It shows. Yeah.
Can you stop share screen from your side, Mr. Jaya,
Yeah,
so that
okay.
the
Okay,
right
I did.
here.
Yes.
Yeah. Okay, can wait a little bit.
Okay, there you go.
Okay.
Okay, very good.
This
Can you start the slide? Thank you. So apologize for the technical difficulties. So the purpose that I want to show the video first before I do the presentation is to tell the audience that the project is already established. The biomass gasification is already implemented in Indonesia in a very remote village in Siberut Island. And Siberut Island is also a remote island in the west side of Indonesia. So I would like to present the concept so NEDO and the representative can understand the challenge and the opportunities of implementing this such new technology in Indonesia. Go ahead, next. Okay, so this is our problem. We have a geographical limitation where we have thousands of islands and we cannot connect all these islands in one main grid, like in China or India or any other ASEAN countries in nearby, in Thailand or Vietnam or Malaysia and so on and so forth. So because of that limitation, the electricity is only reliable and equitable for the majority of population in Java, in the island of Java. But outside of Java, in particular in eastern part of Indonesia, electricity is still quite rare. And if they have electricity, then it's not reliable, it's not equitable, it's not 24-hour per day, it's not 7 days a week. They have a lot of interruption of electricity supply. And this is an ironic situation because Indonesia is rich in energy resources. We have all kinds of energy. Compared to Japan, we are much richer in terms of natural resources. We have oil and gas, we have coal, we have biomass, we have geothermal sources, we have hydro sources, wind and solar everywhere. So we need to bring all this potential and make it the best system and for the maximum benefit of the people of Indonesia, in particular in remote islands. Next. So, and here's the problem: if we don't do that, electricity is a way to develop the remote islands. Without reliable and equitable electricity, then all these rural communities will be condemned to backwardness, to poverty, and to all kinds of social problems. We have maybe around 1,000 kilowatt hour per capita per year of electricity consumption. That's the average, national average. But in rural Indonesia, it's much lower than that. It's probably comparable to sub-Saharan Africa, which is the least developed countries all over the world. So we need to bring electricity to the rural communities all over Indonesia. Next. And just like I mentioned in the beginning, that we are unique. We need a fit for purpose solution. This is a solution that's probably only ideal for Indonesia and probably not in other countries. But we cannot just copy other solution from other countries. And definitely we cannot copy the solution from Japan or any other developed countries because we have a different situation. Next. The first, I think, the characteristic that we need to bring to all islands in Indonesia we need to find energy source that is renewable and can be obtained locally. So the island will be self-sufficient. We don't need to bring energy, primary energy from other islands. And the next, and the second characteristic is that when we harvest the energy, which is in this case biomass, we need to make sure that there is minimal ecological impact, and we need to contribute to reforestation effort in Indonesia. Many of the remote areas in Indonesia, rural communities in Indonesia, they have a lot of degraded land and deforested area. I think the number is about 20 million hectares, 20 million hectares of deforested and degraded land all over Indonesia that can be restored and reforest, and we use the plantation for the benefit of the local population. Next. And the generation system must be dispatchable and scalable. What does it mean? It means that we need to replace the diesel gensets exactly like what diesel gensets does. Diesel gensets is very popular in Indonesia, remote islands, because it is dispatchable. It can be turned on and turned off on demand by the operator. So when the load is more on the evening than in the daytime, then it can be utilized very well. And then it can be scalable. It means that we start from small. Maybe the island doesn't need more than 1 megawatt. Then we put 1 megawatt. If the island being developed and there are industry coming in, then we need to add another 1 megawatt or another n megawatt, and so on and so forth. So we don't need to change the system so much. But if we want to put 5 megawatt in the island that only need 1 megawatt, then it will be a waste of money and energy. So we need to put the generation system that fit for the purpose in that particular island. Next. And the electricity produced must be equitable, reliable, and affordable. It means that we need the population to enjoy electricity regardless of their social status and where they live. Otherwise they will be in poverty forever. Without electricity, there cannot be lighting for them, so they cannot do any activities during the nighttime. It was mentioned in the video, after the electricity comes into that particular village, then the whole village can then be developed. Next slide. So this is the current status in Indonesia. We have the conventional system. So diesel genset is usually built in the city center or in the near the port, and then PLN put all the transmission all over the island. But what happened when the natural disaster strike? They will have no power. Why? Because the transmission goes down. Transmission goes down. Nobody has power anymore, and the diesel genset has no use for the people of that particular island. So it's prone to disaster and disturbance. Even if imagine if the diesel fuel is coming late, what are they gonna do? They just turn off the generators, and then the people doesn't have other source of generation. So there will be a blackout on the whole island because of the late supply of diesel fuel. And it happens all the time, all over Indonesia, particularly in remote islands. And it is very expensive to operate. It is polluting, and it doesn't have benefit to the local population. There is zero social and environmental impact to the local, or even negative actually. But people in that particular island doesn't participate in the generation, doesn't do any good to them, and it just give electricity in a minimum, for a minimum. It's only good for lighting maybe, but it's not going to bring industry into that particular island. So what we want to propose, make it decentralized. It means that all these villages all over the island will utilize whatever they have. If they have a biomass source, then use the biomass source. If they have the hydro source, then put the micro hydro power plant. And then if, of course, they will have a solar PV, we can put a solar PV because suns shine all over Indonesia 365 days a year. I mean, we have no four seasons, just like in Japan. So solar PV can be deployed easily and can be complementing the biomass distributed power. So it will be more resilient to natural disaster. If natural disaster hit, the island will not experience blackout, and they still can do communication to other island, and it will save life if we do this. Okay, and then it's cheaper to operate, and of course, because the biomass is produced by the local population, there will be economic impact directly to local community. So what I want to emphasize in this concept is the government will bring inclusive, green, and resilient growth to the local community. Inclusive, green, and resilient growth, especially during this pandemic, they will be more resilient. They don't need outsiders to help them. They can help themselves during this pandemic because electricity is more reliable, and they are participating in this scheme. Next. And this is the typical system configuration that we have in Mentawai, and we are now also exploring the new project in Nusa Tenggara Timur, in the border area, which is in Atambua, bordering with Timor-Leste. We are cooperating with Indonesia Power, which is the subsidiary of PLN. Same concept, same technology, but different biomass source, because in Mentawai, bamboo is a native species. You can find bamboo abundantly in Mentawai, but in Timor, because of the dry land and also dry weather, Gliricida sepium, we call it gamal, it's more common, and the leaf can be used for cattle feed. So they can use it to feed the cattle, for cows basically, and we use the branches for the biomass feedstock, and it can provide on-demand power. It is scalable, just like in the diesel genset, and can be deployed faster than natural gas fuel power generation. Why? Because we don't need infrastructure to receive the natural gas, usually in form of liquid natural gas or compressed natural gas from other islands. We don't need that. Biomass gasification can be built with minimal infrastructure. That's why it's faster than natural gas. And the producer gas, which is syngas, we call it, can be used complementary to diesel fuel. So it can be set as a dual fuel. So the existing diesel genset can be still utilized, and then we just put the gasifier and fit the syngas into the intake manifold. Next. So this is the business scheme that we developed for Timor. Clean Power Indonesia as an IPP, that's in the middle. And we are partnering with Indonesia Power, subsidiary of PLN. And then the operation and maintenance operator is Indonesia Power. So we will have OM contract with Indonesia Power. EPC contractor, now interestingly, the project in Mentawai was built by Japanese construction company, which is Toyo Engineering, through their local company. It's called IPPT, and IPPT is oil and gas contractor, APC contractor before, but now they're also shifting to renewable energy. So IPPT, which is the subsidiary of Toyo Engineering, has experience to build this project all over Indonesia, and we are partnering with them. We are quite happy with IPPT because they're very professional. It's on schedule, on budget, and they know what they're doing. And the local become the biomass producer, but they will sell the biomass through their local government-owned enterprise, or BUMD, we call it. Why? Because then they will guarantee feedstock to IPP. So IPP is not exposed to the local directly. The local government company, which is mandated by the local government to give feedstock guarantee to the IPP. That's what we need. So the price will be fixed and the volume will be guaranteed. So there is no risk in this power plant. And the lenders, we already discussed with Green Climate Fund, with PTSMI, that's their accredited entity in Indonesia, and they can bring soft loan to this project from Green Climate Fund to through PTSMI. And PTSMI is a special mission vehicle under Ministry of Finance, and their mandate is to bring local empowerment. They need to bring low carbon development all over Indonesia. So we are quite happy to work with the PTSMI. And then, of course, we have a offtake guarantee from PLN. It will be 25 years, 20 to 25 years of power purchasing agreement, which is bankable, and PTSMI will fund this. The tariff is mandated by the Ministry of Energy, so it's a feed-in tariff. So it's fixed. So it's guaranteed tariff by the government under 5 megawatt. There is no negotiation involved with PLN. So this will give security and certainty to the project. Now, what I want to discuss also with NEDO and BPPT, why don't we get the carbon offset scheme as well to this project? Why? Because not only that we have reduced carbon emission through the renewable energy, because we switched from diesel gensets to biomass power plant, but because we reforest the area, and that can be substantial carbon offset. And I understand that Indonesia has bilateral agreement with Japanese government in terms of carbon trading. It's called JCM, Joint Credit Mechanism. So if we can tap into that funding, then this project can be developed all over the Indonesia, regardless of the tariff from PLN. So imagine all the diesel gensets, that's around maybe about 5,000 megawatt, can be replaced with biomass gasification. PLN already targeted 2 gigawatt that needs to be replaced in the next 4 years until 2024. So it's a big opportunity for NEDO and Japanese government through the JCM to be participating in this project. Next. Okay. So
can you please make it more concise to save time? Thank you.
How many more minutes I have?
Let's say 3.
Okay. All right. So this is what we are working on. We want to access the global carbon credit market through BPDLH, and BPDLH is an environmental fund under Ministry of Finance. Their role is to distribute all this carbon credit payment to this project. Next, there are some points. Yeah, so the community can act as consumer as well as producer. Next. And then they will have a extra income from this project. Next. And then we can, so yeah, regardless of the social and educational status, there will be job for all the locals. PLN benefit from the lower cost of local electricity generation, and carbon credit delivers benefit to the locals. Next. This is just a simulation of how much they save. PLN save 16 billion rupiah per year for 2.2 megawatt. So if we scale up to 2 gigawatt, just like what PLN saying that they want to replace 2 gigawatt of diesel genset to renewable energy, biomass, solar PV, and so on and so forth, they will save 16 trillion rupiah. And that 16 trillion majority going back to the locals and local industry in Indonesia. Next. So how many villages all over Indonesia that needs this concept? 50,000. 50,000 villages. This is the number from Ministry of Village Development. There are 50,000 villages all over Indonesia that needs reliable and equitable electricity. Basically, the improvement of electricity access. Not just 2-3 villages, but 50,000. Okay, and then 20 million hectares of degraded and marginal land that can be restored, and the 5,000 megawatt that I mentioned about the diesel genset that can be replaced. Next. So it is going to be we're thinking about the 5 characteristics that I think it's going to be the nature of this project: availability of the feedstock, accessibility of the electricity to the local population, affordability, so the communities can pay because they have money coming into their pocket, so they can pay electricity, acceptability because the biomass is planted on degraded land. We are not deforesting a primary forest. We don't touch primary forest, but on the other hand, we restore deforested area. And sustainability is guaranteed because the feedstock is guaranteed, access of electricity guaranteed, and we bring a resilient landscape and growth. Next. I think we just skip this. Next. Okay, so this is the last slide. So before, yeah, okay, thank you. So I would like to emphasize that after the pandemic, the government need to create jobs. It's jobs. That's very important that we created all over Indonesia, not just in Java, but also in eastern part of Indonesia. So, and then the cost efficiency of PLN distributed power need to be improved by switching from diesel gensets to local renewable energy, and energy self-sufficiency for local all regions. Indonesia is important because otherwise we cannot develop. We cannot develop remote islands, remote area all over Indonesia without providing energy self-sufficiency. So the government will need not only to bring this improvement to all over Indonesia, but also to achieve the target of 23% of renewable by 2025. Minister of Planning Agency, which is Pak Bambang Brojonegoro, mentioned this in the video, and he's now the head or the Minister of Research and Development, also the head of the supervisor of BPPT. Then I think it's very important for the government to take a very active role in this. And I believe biomass distributed power will be the key. Thank you, Mbak Novi. Get back to you.
All right, thank you very much for Mr. Jaya Wahono for sharing with us. I think the project developed by Clean Power Indonesia seems very interesting, especially how the projects are working in remote areas so that the energy or electricity can be enjoyed equally by all the Indonesian people. Particularly, the use of bamboo is very interesting, I think. And then I noted the invitation from Clean Power Indonesia to BPPT and NEDO regarding the carbon offset scheme that may be submitted as joint credit mechanism. So I hope this can be followed up later. All right, so I would like to remind again to invite the audience to ask question or give a comment on Q&A chat. And so far, we have one question that actually has been answered by Ms. Andrea. So for this session, I am informed by the organizer that I have to translate it to Indonesian first and then translate it to Japanese by interpreter. And then for the answer, we can read, we already have the answer from Miss Andrea here in the Q&A. However, I think Miss Andrea can give more, how to say, information regarding this electricity tariff. So, okay, let me read the question. In Indonesian, in English first. Will Indonesia government plan to introduce subsidies such as feed-in tariff to promote the use of biomass energy in order to achieve the 23% renewable target in 2025? From Ryu Lee, Senior Manager of Hanwha, Thailand. So, in Indonesian, apakah pemerintah Indonesia berencana untuk mengintroduksi subsidi seperti feed-in tariff sistem scheme untuk mempromosikan penggunaan energi biomasa untuk mencapai 23% target energi terbarukan di tahun 2025. Interpreter will interpret this question first to Japanese.
インドネシア政府は2025年に再生可能エネルギー 23% の目標を達成するためにバイオマスエネルギーの使用に固定価格の買取制度などの補助金を導入する予定はありますか?
Okay, thank you. So, so I think to Miss Andrea, can you please kepada Ibu Andrea, mohon bisa mungkin ditambahkan lagi informasi mengenai feed-in tarif ini, Bu.
Oke, ini jadi bahasa Indonesia aja, Mbak. Gimana?
Bahasa Indonesia. Iya, bahasa Indonesia aja, Bu.
Masih ditranslate ke bahasa Jepang ya? Ya, saya sudah menjawab tadi bahwa memang untuk saat ini kita sedang menyusun Perpres untuk tarif listrik yang berbasis renewable energy, di mana memang untuk yang regulasi Perpres yang baru ini kita memberikan feed-in tarif ya, di mana harganya itu nanti dibuat staging, jadi 10 tahun pertama itu harganya lebih tinggi, feed-in tarifnya lebih besar daripada kemudian sisa dari waktu kontraknya. Karena harus diterjemahkan ya, jadi saya harus berhenti dulu ya.
Ya. 再生可能エネルギーの新しい制度にはバイオマスやバイオガスによる電気料金に関する固定価格買取制度 FIT があります。Lanjut, Bu.
Ya, jadi untuk feed-in tarif ini nanti untuk berbagai jenis renewable energy, jadi termasuk energi matahari, kemudian energi angin, kemudian panas bumi, termasuk biomasa dan juga biogas.
で、こちらのFIT の補助金はすべてにおいて可能になります。太陽エネルギーだったり、再生可能エネルギーだったり、すべてのバイオマスだったり、すべては有効になります。
Harapan kami nanti dengan Perpres yang baru ini bisa lebih menarik minat para investor untuk bisa mengembangkan energi terbarukan di Indonesia.
なので、この大統領の例、新しい大統領例が出たら、海外からの投資家がより魅力的に感じられると思います。
Oke, baik, terima kasih. Saya mungkin informasikan kepada pembicara apabila ingin menjawab pertanyaan bisa juga diketik begitu ya di sini supaya bisa juga merespon langsung. Selain memang kita akan angkat ke sesi Q&A ini. Oh ya, harus ditranslate dulu ya.
なのでこちらに Q&A の欄に質問を書いていただいたら直接スピーカーからの回答も可能になります。
Oke, baiklah. Untuk pertanyaan berikutnya kita punya dari Ini dalam bahasa Inggris. Based on your experience, we need to know the cost of biomass as fuel for power plant and how it is managed to boost the income for the farmer. And unfortunately, ini nggak ada siapa yang tanya ya. Oke. Can you please translate first this question?
質問する方がちょっと分かりませんが、この、今までの経験において発電機の燃料のためのバイオマスのコストはどれだけかかるかのコストを知りたいです。
Oke, untuk pertanyaan ini mungkin lebih pas ditujukan ke Pak Jaya Wahono, tapi tentu saja mungkin Pak Joko Winarno dan Ibu Andrea juga Pak Sumbogo boleh juga memberikan pandangannya mungkin nanti. Silakan kepada Pak Jaya dahulu.
Ya, terima kasih Mbak. Saya bahasa Indonesia aja nanti diterjemahkan ya. Jadi harga biomasanya yang diterima oleh masyarakat itu Rp150 per kilogram, tetapi kemudian dijual oleh BUMD ke pembangkit seharga Rp300 per kilogram. Jadi dari perhitungan itu 5 megawatt rencananya yang di Timor itu bisa memberikan 1,2 miliar per bulan. 1,2 miliar itu mungkin ya sekitar 100.000 US dollar ya. Itu untuk BUMD dan masyarakat sekitar 100.000 US dollar per bulan. Itu yang dampaknya ke masyarakat langsung baik yang diterima oleh masyarakat maupun BUMD setempat. Saya kira itu. Sementara.
バイオマスの価格は、そちらにローカルの、民間は、150ルピア、キログラムあたり150ルピアです。でそこから、国営企業、地方の国営企業に売る価格がキログラムあたり300ルピアになります。でそしたらティモルの例え、さっきのティモルの例えにすると5メガワットは10万ドルの売上が認められます。Oke, Pak.
Oke, ada lagi tambahan dari Pak Jaya atau cukup?
Cukup. Silakan dari Pak Joko dan Bu Feby.
Ya, silakan Pak Joko dan Pak Joko mungkin pertama ya, barangkali ada yang ingin ditambahkan mengenai ini biaya biomas.
Pertanyaannya mengenai apa ya tadi, harga ya?
Mengenai harga Pak. Mengenai harga.
Aduh, kalau harga itu memang perhitungan kita dengan memanfaatkan hutan tanaman industri energi itu masih di harga sampai di lokasi itu masih sekitar Rp950 Pak. Jadi dengan perhitungan investasi penanaman, land clearing, dan pemeliharaan selama 2 tahun, terus nanti kita shipping, terus kita transport ke lokasi, itu jatuhnya memang masih cukup mahal, Rp950 per kilogram. Nah, jadi ada kemungkinan caranya adalah kita harus bekerja sama dari hulu sampai hilir, termasuk penjualan listriknya. Jadi kalau ini mendapatkan suatu pembangkit listrik dengan komplit mulai dari penanaman sampai dengan pembangkit listriknya lalu dijual, itu ada kemungkinan ada subsidi silang Pak antar itu. Jadi kalau masing-masing berdiri sendiri seperti perhutani, dia menjual Rp950 per kilogram, jualnya kepada pembangkit. Nah nanti pembangkit di sini dihitung ada untung, lalu pembangkitnya juga menjual ada untung lagi, jadi harganya menjadi agak tinggi. Tapi kalau ini bisa menjadi satu kesatuan, jadi keuntungannya itu semua dari hutan juga punya share di pembangkit, itu akhirnya nanti harganya bisa memenuhi kepentingan daripada peraturan dari peraturan pemerintah atau harga EBT yang sudah akan dicanangkan oleh akan ditandatangani oleh Presiden. Kira-kira kalau analisa saya seperti itu, Pak. Tapi kalau kita berdiri sendiri-sendiri, memang harganya agak menjadi mahal. Karena kita biaya tanam selama 2 tahun juga cukup tinggi. Jatuhnya sampai di selesai penanaman itu, sampai dengan panen itu sudah Rp400 per kilogram. Belum lagi kita membuat industri shipping sama transport, itu yang menjadi tinggi. Terima kasih.
Terima kasih Pak. Silakan diterjemahkan dulu.
ジョコウィナルノ様の回答によりますと、今のところは、キログラムあたりエネルギー、進化の産業林からのエネルギーは、キログラムあたり950ルピア。まだこれだとだいぶ価格が高くなっております。でなのでなんていうの、クロス補助が必要になります。OK。
Sudah cukup? Baik, ya, untuk kita ada pertanyaan dari Ibu Yusnitati mengenai data yang diperoleh selama ini bahwa biaya biomasa untuk power plant itu 800.000 per ton, sementara PLN hanya mampu membayar 400.000 rupiah per ton. Jadi tidak masuk katanya begitu. Apakah ada komentar dari rasanya ini bisa, terutama ke Ibu Andrea dulu ya? Mungkin selanjutnya boleh para pembicara yang lain. Silahkan.
Saya terjemahkan dulu ya, Bu ya.
Iya.
Itu今いただいている情報ですと、PLN が出している発電機のバイオマス使用のコストが80万、ini rupiah ya, 80万ルピア、トンあたりが180万ルピアになります。で、一方、PLN が支払える金額が40万ルピア、トンあたりが40万ルピアしか支払えない。それ計算式はちょっと合わないんですが、どんな感じですか?
Baik, mungkin saya bisa jawab ya. Oke. Ya, tadi seperti yang disampaikan oleh Pak Joko Winarno, ya memang kalau untuk harga dari biomass ini ya masih memang bervariasi ya. Ya tergantung tadi lokasinya di mana, makanya memang untuk yang co-firing ini, untuk jangka pendek kita memang mendorong untuk menggunakan limbah ataupun dari sampah, karena memang harganya itu yang sesuai dengan harga yang mampu dibayar oleh PLN. Kalau misal menggunakan yang berbasis tanaman energi, ini memang masih harganya tinggi. Nah ini mungkin untuk jangka panjang lah nanti akan kita lihat seperti apa untuk menjamin agar harganya itu juga tidak membebani PLN ataupun membebani konsumen. Karena kalau misal harganya bahan bakunya mahal, artinya kan harga listriknya juga akan menjadi tinggi dan biasanya ini kan akan dipass-through ke konsumen. Makanya untuk sementara, untuk yang co-firing ini, untuk jangka pendek ini kita menggunakan limbah seperti sodas ya, ataupun menggunakan RDF ataupun SRF yang dari sampah kota, sehingga harganya itu tetap bisa masuk dengan harga PLN. Gitu.
Oke. 先ほどジョコさんにお伝えしましたように、今バイオマスの価格がそれぞれあります。で、その場所はどこ、場所の位置までどうやってどれだけのコストかかるかとか、 なので、先ほどお勧めした提案としては、コファイリングっていうことになります。で、コファイリングの場合は、なんていうの、ゴミ、廃棄物を使ってるので、割と価格としては安くできます。で、ここでのポイントになるのは、この価格は PLN 側もそこに住んでいる民間たちの負担にならない程度の価格設定をしなければいけない。
Oke.
Baik,
Baik. Ya, ada lagi mungkin tambahan dari Ibu Andrea terkait hal ini? Sudah cukup barusan, Bu? Oke, baik. Saya juga ingin memberikan kesempatan kepada Pak Sembogo juga untuk memberikan komentarnya barangkali terkait dengan biaya ini tadi.
Cukup disampaikan oleh Ibu Andrea Febi Misna.
Baik, baik, terima kasih. Selanjutnya kita mungkin terbatas sekali waktunya ya, jadi mungkin hanya satu maksimal atau dua lah paling terakhir untuk saya sampaikan pertanyaannya. Mungkin diterjemahkan dulu aja ya, Mbak.
時間が限られているので、あと1つか2つの質問しか言えません。すいません。
Ya, terima kasih. Oke, ada pertanyaan ini saya kurang bisa membaca dari siapa, tapi pertanyaannya terkait palm kernel shell atau cangkang sawit begitu ya, diimpor ke Jepang untuk energi. Nah, apakah ini ada dampaknya terhadap energi strategi di Indonesia karena kita mengekspor cangkang sawit ini ke Jepang seperti itu.
Okay. 発電機の日本での発電機のために PKS をインドネシアから輸出する、日本側に輸出することが多いんですが、それってインドネシアのエネルギーの戦略に何か影響がありますか?
Baik, untuk pertanyaan ini saya persilahkan kepada seluruh pembicara ya, barangkali ada komentar, mungkin bisa saya persilahkan ke Pak Joko. Mungkin barangkali ada komentar terkait ini. Halo Pak Joko, monitor Pak. Ada pertanyaan Pak mengenai ekspor cangkang sawit ke Jepang. Apakah ada dampaknya terhadap penggunaan energi biomasa di Indonesia?
Ya, udah pasti dampaknya banyak sekali, Bu. Jadi sekarang yang sudah terjadi hampir tidak ada lagi cangkang yang bisa dipakai di dalam negeri karena mereka lebih suka diekspor karena harganya mahal gitu loh. Jadi itulah yang menjadi pemikiran kita, yang paling tidak kita harus bisa mengganti kebutuhannya dengan wood chip. Jadi banyak industri-industri yang selama ini udah pakai cangkang atau PLN sendiri juga udah mencoba pakai cangkang, tapi begitu implementasi dicoba berhasil, begitu minta dibeli dia nggak mau jual dengan harga yang murah gitu Pak. Karena mereka lebih suka diekspor karena itu ya hukum ekonomi. Jadi pengaruhnya udah pasti banyak. Nah, untuk mengatasinya memang kita mencoba menawarkan untuk co-firing ini dengan hutan tanaman energi. Jadi tinggal nanti bagaimana komprominya adalah harganya bisa diterima oleh PLN, tetapi juga kita punya yang continue. Jadi kalau memang tadi Bu Febri juga menjelaskan hanya mengandalkan dari limbah, itu yakin juga tidak akan bisa continue. Seperti kemarin yang dilihat di Python itu ternyata dia pakai sodas itu hanya 1%, bahkan mungkin cuma 0,5% Bu kenyataannya, karena sodas yang dari hasil beberapa banyak somil-somil yang ada di Jawa Timur juga kapasitasnya kecil sekali. Jadi itu yang kita lihat. Nah, jadi memang sekarang kita harus mencari jalan kompromi bagaimana supaya PLN bisa beli, tapi juga tidak harus import gitu loh. Jadi kita bisa memanfaatkan hutan yang sekian banyak sudah disiapkan oleh pemerintah untuk kita tanam hutan tanaman energi. Ya, sementara waktu mungkin memang kita lebih banyak mungkin membangun PLTBM saja daripada kita masuk ke co-firing, karena dengan co-firing harganya belum cocok. Kalau tidak ada aturan pemerintah yang mendukung, nanti juga akan kesulitan. Terima kasih.
Baik, terima kasih Pak. Bagaimana Sisa, silakan.
もちろんPKS は日本に輸出する、たくさん輸出されるっていうところの影響がたくさんあります。で、例えばその結果、国内でのその PKS がなくなっているのが現状です。なぜかっていうと、やっぱ日本に輸出した方が値段が高いので、国内での PKS がなくなってしまいました。で、そうしたら他の方法はエネルギー森林を有効に使えることです。以上です。
Ya, baik. Terima kasih atas jawabannya. Mungkin dari Bu Andrea sepertinya bisa menambahkan komentar ya, Bu.
Maaf, saya sedang menjawab ini. Kenapa tadi pertanyaan
tentang ekspor cangkang sawit ke...
Tadi sebenarnya Pak Joko sudah memberikan penjelasan yang sangat-sangat clear ya. Jadi dengan adanya ekspor cangkang itu ke negara-negara lain, ya memang dampaknya di harganya menjadi sangat tinggi, dan itu menyebabkan harga di dalamnya yang kita tidak mampu untuk membeli. Nah, ini mungkin ke depan yang memang apakah nanti akan diatur, ada DMO yang masih dalam inilah ya, masih dalam pembahasan ke depan nanti akan seperti apa. Tetapi tadi Pak Joko juga menyampaikan bahwa kita mempunyai sumber lain yang cukup banyak juga. Jangka pendek mungkin Pak, ini saya sih menyampaikan jangka pendek ini memang kita menggunakan limbah, itu kan mungkin hanya jangka 1 tahun, 2 tahun ini sambil kita mempersiapkan tanaman energi pastinya. Ya mudah-mudahan ke depan memang mau tidak mau kita memang harus rely on tanaman energi, karena kalau tidak ya memang tidak akan sustain bahan baku. Nah, untuk yang jangka pendek ini co-firing memang concern kita dorong untuk bisa segera komersial, kemudian menggunakan dengan sumber-sumber yang ada di lokasi setempat ya, supaya nanti harganya tidak mahal. Kemudian juga persentasenya jangan tinggi-tinggi dulu, jadi disesuaikan apakah itu hanya 1%, 2%. Kalau dilihat mungkin wah itu terlalu kecil, tidak berdampak, tetapi kan ini kita masih dalam tahap memulai. Jadi nanti kalau pasarnya sudah terbentuk, insya Allah ini kita bisa tingkatkan lah ke depan.
はい、先ほどジョコさんがおっしゃる通り、現状の PKS の国内での PKS の価格がものすごい高くなりました。そしたら国内での需要がこの PKS からはカバーしきれないため、他の方法は今考え中です。この1年2年の近い将来はとりあえずその廃棄ゴミだとか廃棄物を使うようにしています。で、これからはそのルール、規則とか制度を作りながらエネルギー植物を使えるような制度にしていきたいと考えています。
Oke, baik, terima kasih. Sepertinya waktu kita sudah sangat terbatas, tetapi izinkan saya untuk mengangkat satu saja lagi pertanyaan terakhir dari Q&A ini, yaitu ditujukan kepada Pak Sumbogo. Apakah sudah dilakukan perhitungan keekonomian bottling bio-CNG? Di skala minimum berapa bottling bio-CNG ekonomis? Terima kasih. Dari Pak Muhammad Aman. Diterjemahkan dulu, silakan Bu Tisa. Di answer.
OK。バイオ CNG の経済的な計算をもうすでにしてあるのかどうかの質問です。OK。
Ya.
Sudah ya?
Baik.
Ya.
Baik, terima kasih Pak Muhammad Aman. Kami di BPT secara langsung belum melakukannya, tetapi kami sedang melakukan kajian untuk minimal keekonomian terkait dengan pemanfaatan biogas menjadi bio-CNG. Dan kebetulan besok pagi salah satu temanya adalah pemanfaatan biogas dari POME yang akan disampaikan oleh Bapak Dr. Muhammad Abdul Khalik. Beliau adalah Direktur Pusat Teknologi Lingkungan dan sekaligus Ketua Asosiasi Biogas Indonesia. Mungkin silakan besok bisa join lagi, Pak. Demikian yang bisa saya sampaikan. Terima kasih.
はい。今のところはまだ計算中です。今最低の計算をやってるところです。で、明日のプレゼンテーションはまさにこの関係のプレゼンテーションがございますので、また明日お聞きください。
Oke, baik. Terima kasih atas jawaban dan pertanyaannya dari semua hadirin. Satu saya beri kesempatan lagi kepada Pak Jaya. Mungkin terakhir ada komentar sedikit saja Pak, yang singkat saja.
Oke, terima kasih. Mungkin singkat saja. Menurut saya kerjasama Jepang dan Indonesia melalui BPPT dan NEDO ini sebaiknya diarahkan pada pengembangan teknologi yang tepat untuk melistriki daerah tertinggal, karena itu yang sangat dibutuhkan di Indonesia. Apakah melalui JCM, apakah melalui skema funding yang lain, melalui JICA dan lain-lain. Saya kira itu. Jadi teknologi yang tepat untuk melistriki daerah tertinggal, kita butuh kerjasama dari Jepang. Terima kasih.
Ya, silakan Tran.
一つ追加の一言なんですけれども、インドネシアの BPPT と日本の NEDO がこれから先その共同でやるとしたら的確な技術の開発ですね。特にインドネシアの、田舎まだ電気が行ってない田舎だったりっていうところがものすごくこの GCM の制度を使ってたり JICA の制度を使ってたり、これに応じてインドネシアの BPPT と日本の NEDO が合理的に一緒に仕事ができたらと思っています。
Oke, baik, terima kasih. Izinkan saya menggunakan bahasa Inggris untuk penutupannya. Okay, thank you very much for the Q&A session. I think it's time for me to close this session. Very sorry for the delay, but I think the delay is actually to hear more about the comments and opinion as well as information from the speakers. So today we learned and listened about the lesson learned or what have been done by all the speakers, the organization, and what to improve in the future, and also the future opportunity, what to develop, and then what to collaborate, not only between Indonesian but also with Japan particularly, or even other countries. And opportunity to share the thought, although the time is very limited, but I believe there will be future opportunity, and this today is the chance for the Japanese side especially, I think, to listen more about the policy, the Indonesian experience, the technology that being developed in Indonesia related to biomass. And I believe, I hope in the future, especially the Japanese audience can later together with us develop future collaboration. And but of course, in order to implement the renewable energy share to 23% in 2050, we need participation from all the stakeholders, not only the association to give the suggestion, also from the private company to implement from the business perspective, and then from technology developer like PPPT, or from Japan to give an advice based on the research and application of technology. So I think there are still a lot of work that we have to do together, and hopefully we can together achieve the success of the implementation of biomass energy in Indonesia, together collaborating with international party, for example, from Japan. I think that's all from me. I would like to remind that tomorrow until Thursday, we still have more sessions, and it will be more about technology aspect for the tomorrow. As Mr. Sumbogo mentioned, we'll talk about biogas, and then the next day is about plantation. And then the last day, it will be about high value added. So we are not just gonna talk about energy, but also high value product that we can obtain from biomass, which is also, I think, very, very interesting. So please don't miss the tomorrow and the upcoming days for this webinar. Thank you very much for giving me the chance to chair this session. I would like to give the time and screen back to the MC. Thank you.
Baik, terima kasih kepada Ibu Andria Febinisna, Bapak Joko Winarno, Bapak Sumbogo Murti, Bapak Jaya Wahono atas presentasinya yang sangat bermanfaat. Dan untuk materi presentasi nanti akan diberikan kepada peserta setelah peserta mengisi link evaluasi.
スピーカーの皆様、非常に有用なプレゼンテーションをありがとうございました。こちらのスピーカーの皆様の資料は、アンケートをご記入していただいた方に提供いたします。
Terima kasih juga kepada Ibu Novi Safika yang sudah memandu sesi tanya jawab dengan sangat interaktif dengan para pembicara yang sudah menjawab pertanyaan yang sudah diajukan.
質問に答えたスピーカーや質疑応答のセッションを盛り上げていただきありがとうございました。
Baiklah Bapak Ibu, kita telah sampai di penghujung acara webinar kita hari ini. Sebelum saya menutup acara ini, terdapat beberapa informasi terkait webinar di tanggal 15 sampai 17 Desember dan terkait pengisian form evaluasi untuk mendapatkan sertifikat. Bagi Bapak dan Ibu yang ingin mendapatkan sertifikat, mohon dapat mengisi link evaluasi yang ditunjukkan pada layar Bapak dan Ibu.
本日ウェビナーが終了となりますが、その前に2020年12月15日から17日までのウェビナーおよび評価フォームの記入に関するいくつかの情報があります。証明書を取得したい方は評価リンクと QR コードが画面に表示されるところにご記入をお願いします。
Bagi Bapak dan Ibu yang bersedia menjawab kuesioner, akan diberikan materi yang memuat resume teknologi dan kontak dari 3 perusahaan Jepang yang memberikan presentasi di hari kedua, hari ketiga, dan hari keempat. Dan tentu saja materi yang diringkas berisi informasi skema support dan kontak 7 lembaga publik Jepang yang memberikan informasi di dalam webinar ini. Oleh karena itu, mohon kerjasamanya untuk menjawab kuesioner. Pada tanggal 15 sampai dengan 17 Desember nanti masih ada webinar lanjutan dari hari ini. Bagi Bapak dan Ibu yang belum mendaftar, dapat mendaftar melalui link terlampir.
積極的にアンケートをご記入の方に2日目から4日目のプレゼンテーション資料や日本企業3社の連絡先を提供させていただきます。そしてサポートスキームや7つの公的機関の連絡先も提供しますので、アンケートのご協力をお願いします。明日から17日まで引き続きウェビナーがございますので、まだ登録していない方はどうぞ店舗のリンクに登録してください。
Terima kasih Bapak dan Ibu atas partisipasinya hari ini. Mohon maaf bila selama memandu acara terdapat hal-hal yang kurang berkenan. Semoga kita bisa ketemu kembali di webinar selanjutnya. Selamat siang dan selamat kembali beraktivitas.
本日はウェビナーに参加いただき誠にありがとうございました。イベント中は何か不備がございましたらお許しください。次のウェビナーに会えるのを楽しみにしています。皆様本日ありがとうございました。
Arigato.
Terima kasih Bu Andria.
Ya, terima kasih semuanya.
Terima kasih Bu Andra, Bu Febi. Terima kasih.
Pak Sumbogo, Pak Jaya, Mbak Novi.
Ya, makasih Pak Joko Winarno, Pak Jaya. Makasih semuanya.
Izin Liv ya, makasih banyak. Assalamualaikum.
Ya, izin Liv.
Sukses ya acaranya. Sampai 4 hari ya?
Terima
Sampai
kasih
Kamis
Bu.
ya?
Betul Bu, betul.
Iya Bu.
Oke, sukses.
Iya.
Terima kasih Pak Sumbogo.
Terima kasih semuanya. Terima kasih Pak Hens.
Terima kasih Pak Hens.
Ya, terima kasih semua.